Good morning, everyone. This is Shauna, and this video is going to cover section 8.5, hypothesis testing with standard deviation and variance. Before we actually get started, I'm going to make a couple of general remarks. Professor Nickdell asked me to mention that some of you who are taking the class online lost some points on the homework assignment that we just recently turned in for not following the proper hypothesis testing instructions. Remember, those are there on Canvas for you. They include things like writing the 5 steps that if you're watching these videos, you've seen me do over and over again, boxing the step numbers, writing the front part, which is the type of test you're doing and the claim and the method that you're doing it by. That's also there, and underlining in your decision is or is not, and reject or do not reject. So I'll be pointing that out as I go along again in these problems here, but I just wanted to mention that briefly. I'm going to share my screen and share the homework assignment at this time. Now, before we actually get into, there are 9 problems on this homework assignment. Before we actually get into the homework assignment, there are a couple of problems here that have multiple parts that are going to allow you to practice finding the critical values and finding the p-values for chi-square test. And that's because it's a little bit different, just like finding the confidence interval was a little bit different. So by way of explanation here, let me also do this. This is a printed version of the page that's on your Canvas page for this lesson. It's critical values for the chi-square test for decimal places. So remember, critical values apply if you're using the traditional approach, and you're going to be using your inverse chi program that you used previously when you were doing confidence intervals for the standard deviation and the variance. So your significance level is alpha. If it's a right tail test, you're going to use the critical value as inverse chi, alpha, and DF. For a left tail test, you have inverse chi squared and 1 minus alpha and DF. But if it's a two tail test, there's a little nuance that you should be aware of. And we're going to see that in our exploration. I just want to point this out. The two-tailed test has obviously 2 values, okay? Both of them are positive, remember. Chi-squared is not symmetric. So chi-square test and chi-square distribution have 2 positive values, and you have to put them in separately this time. So for one of them, you have alpha over 2 in DF. You also have 1 minus alpha over 2 in DF. Those are the critical values. For the p-values, it's very similar. Those you're going to be using the chi-squared CDF distribution. That's on the distribution menu in your calculator already, okay? But the inverse chi, remember, you had to program yourself, or you had to get from Professor Nickdell if you're watching this and you saw her on campus and she gave it to you. For a left tail test, chi-squared, I'm sorry, for a left tail test, chi-squared is going to be greater than 0 because they're all positive, but you're going to use the area from 0 to whatever your chi-squared value is and the degree of freedom. For a right-tailed test, you're going to be going from chi-squared to infinity with df. And for a two-tailed test, this is where it gets interesting because it depends on which tail your chi-squared is closer to. So if chi-squared is less than your degree of freedom, this is our nuance. And we'll go over this later. I just wanted to point this out before we started. Okay, so as I mentioned here, problem 1 is talking about finding the critical value or values for each. Show the critical and non-critical regions and state the appropriate null and alternative hypotheses. So we're not doing a full-blown hypothesis test, but basically we're doing steps 1 and 2 here, just for you to practice the format. Use the fact that sigma squared, that's the variance of the population, okay? Sigma squared is equal to 225. You have 4 separate problems to do. She's given you down here, I'm featuring the solution right now that I'm going to take you through. She's given you the rules down here. Alpha is 0.05, N is 18, and it's a right tail. So what we're looking at here, and I'll scroll down in a minute, but basically, this is for part A. So here's my distribution. And chi-squared, remember, is skewed. So it looks something like that, right? Now it's right-tailed. So it's going to be somewhere over here, okay? Say this is where my critical value is, right there, okay? Now, that means that this area to my right, the area is 0.05. Okay. And remember also that because we're not negative, chi-square values are not negative, we're starting here from 0. Okay. Now, we don't know what this chi-squared value is. We don't know what this CV is. We want to find that. Okay. N is 18. When we don't know what a value is and we have an area, we use an inverse. So this is going to require an inverse chi situation. So it says for a right-tailed test, it's inverse chi of alpha and df. So what we're going to do is we're going to go to the calculator here. And remember to get to your, I'm assuming that your calculators have been programmed. We did this back in chapter 7. You can also find a video where I go through it. It's one of the embedded tutoring videos where I go through it if you still need programming. Program here, inverse chi, enter twice, area to my right, as I indicated in the picture, is 0.05. I'm going to hit enter. My degree of freedom, if you remember, my N was 18, so my DF is 1 less. And my critical chi, we want 4 places, 27.5871. 27.5871. So here, I'm going to scroll down and show you that, in fact, there it is, 27.5871. And she wants you to draw this just so you can practice it, okay? So you have a distribution skewed, okay? And this y-axis is there to remind you that we start from 0. 0 is not in the middle of the distribution this time, it's on the very end, okay? And our critical value, as we said, is 27.5871. Now, if it's a right tail test, then here we're going to have now, because we don't have the, unless then we did this, she put equal here, okay? Equals to 25 versus greater, it's a right tail, okay? Let's do another one. The next one she gives us on the homework is alpha is 0.10, n is 23, left tail. Now, alpha is 0.10, n is 23, left tail. So here we go with that. We have our distribution. Now remember that your chi-square goes from 0 to infinity out here, right? This is a left tail test. So we don't know exactly where we are, but we have to be on the left side of this hump. So we're gonna maybe put it here, okay? And this is my CV, this is my chi-square value that I don't have, right? Now, again, we're given here that alpha is 0.10 and n is 23. So we have this. Alpha is 0.10, n is 23, and it's left tail. Okay. So here we're looking for a CV, so we're going to do inverse norm. I'm sorry, inverse chi-square, inverse chi-square, inverse chi-squared, and what? Well, it's inverse chi-squared 1 minus alpha, okay? So 1 minus alpha and df, okay? So here, my alpha region, this region is 0.10. So this region is 0.10. And that's, we're looking for the critical value associated with that. So what we're going to do is we're going to say this. We're going to say that my chi-square value, and it looks like an X, but it's a little fancier and it's the Greek letter chi. So chi-square equals, in this case, it's going to be equals inverse chi 1 minus 0.10. And remember, my df is 1 less than my n. So 23 minus 1, 22. Let's put it in and see what we get. So I'm going to say, go to program, go to inverse chi, enter, enter. Area to my right is 1 minus 0.10. And I'm going to enter. And my DF is 22. 14.0415. Remember there's a 9 behind the 4 here. 14.0415. So this is chi squared is 14.0415. That's my chi-square number. Okay, let's do the next one. Oh, I need to, excuse me, I need to state my hypothesis. So let me give you that. Here we have equal to, and it's versus less than, because it's a left tail test. Okay, now C is a little different. C is 2 tails. Okay, alpha is 0.05, N is 15, and 2 tail. So we have another distribution, another drawing. Whoops, that was bad. I can do better than that. Let's try this. Here's my line. There's my data, right? Now, here's my drawing. So remember, we start from there. We have a big hump, and then we have a big drop. So like so, okay? And it's got a 2 tails. So we've got something like this maybe. And we've got something over here, okay? Now, we have alpha is 0.05. My N is 15. And it's 2 tails. So what I'm going to do is I'm going to say the following. I'm going to say that I need to split the alpha, right? So I have one critical value over here, which is going to be different, not just in magnitude, but remember they're both positive, and one over here, okay? So I'm going to call this my left critical value, and I'm going to call that one my right critical value, just to make things a little bit easier for us, okay? Now, my left critical value is going to be just the same as when we did a left-tailed test. So if I go back to show you this, if I go back up here look at the instructions. For a left tail test, your critical value is inverse chi of 1 minus alpha in df. So for here, you're going to put in, this one is going to be one minus alpha over 2 and df, okay? Because I have to split the alpha when I have two tail. So 1 minus alpha over 2 in df. Let me show you that again. So here, we're doing a two-tail test. So 1 minus alpha over 2 in df, and then alpha over 2. So let's see. Let's get the calculator out. And remember here, this was for part C, alpha is 0.05 and n is 15. So we have program inverse chi, and we're doing 1 minus 0.05 divided by 2. df, remember n was 15, df is 14 here. And my first one is 5.6287. 5.6287. So yeah, so here I actually got this bottom one first on the left, 5.6287. The one on the right, you're going to do in a similar way. You're just going to enter 0.05 over 2 with 14. We get program inverse chi. This is going to be remember here, you're dividing the alpha region by 2. Whoops. Divided by 2, right? And then $26.1189. Okay. So and there it is, 26.1189. Remember, since this is a two-tailed test, you'll have equal to versus not equal to. And we're going to do another two-tailed test. I'll leave this one on the screen for you to practice. You can pause the video if you choose. Remember, you need to draw these. She specifically asked in the instructions for you to draw this. Okay. So I'll leave that there. Pause the video if you need more time. But the next question, the next thing that we need to learn to do is p-values. So I'm going to practice a couple of these p-values with you. So you see how the p-values work. Again, refer to the task sheet that I referred to earlier. Let me get the assignment for us here. So here's our assignment. This is our homework assignment. Find the p-value interval for each chi-square test value. Right? Again, you pay attention to whether it's right tail, left tail, or two tail. This time I'm going to skip to the two tail one because I think that's the one that gives people the most problems. So sigma squared is equal to 24.672, and n is 11, and it's two tails. So this is when you've gotten your test statistic. So we have what's happening here is we've got here's my 0. Okay. And here's my chi, which was 24.672. So this is chi squared. I'm just going to write it as x2 here. And it was 24.672, but it was two tails. Okay. So we know we have another tail over here somewhere. Now, what else do we know? Well, I want to know what the p-value is, right? So here, n is 11, and I have a 2. So here, this is what we've got. And this is not chi squared. I'm sorry. This is sigma squared. So let me fix that. This is sigma squared. Sigma squared is 24.672. And remember, we need the chi-square value to find the p, right? Now, the question is, see, when we go from 0 to chi-squared, we don't know if it's actually in the left tail or the right tail, but there's a little trick for that. And we know that here, n is 11, right? N is 11. DF is equal to 10, obviously, right? Now, here's where the nuance comes. Let me give you here is what this looks like. For the p-values, we're doing letter C. right now, doing the two-tail, because that's the one that I think will give you trouble, okay? The two-tail test, you double the area that you get, but it depends on what chi-squared is. Is chi-squared less than your degree of freedom? If so, then you're on the left side. If chi-squared is more than your degree of freedom, then your p-value is twice the area and your chi-squared is past your degree of freedom, okay? So in this case, if you remember, let's scroll down so I can show you. In this case, if you remember, my chi-squared is 24,672. My DF is 11 minus 1, which is 10. Therefore, it's larger than my degree of freedom. Chi-squared is larger than my degree of freedom. And so when I put this in, and I don't need the inverse chi, I do need the chi-squared CDF on the distribution menu. I'm going to go from chi-squared to E99 with my degree of freedom for that, okay? So how does that look? That looks like this. We're going to go not into your program, but I'm going to quit from here and clear it just to make it easier. When you're doing p-values, you go second distribution, look for something that says chi-squared CDF. Okay, so we're going to go here. We're going to go to chi-squared CDF, and it's going to say lower. Okay, well, my lower is my left. So in this case, you look at the work here, we're going to end up with 24.672 E99. So this is okay. So we have 24.672. My upper is E99. So I'm going to go back into E99. My DF is 10. Paste it. Now, remember, I have to double that number. If I had remembered to, I could have put the 2 times in first and gone there, but I'm just going to do it right now. I'm going to multiply by 2. And that is 0.0120. So here, I have my p-value for a two-tail test. I will leave the other solutions up for you for this portion of this section. You didn't have to state them on the alternative except for part 1. So I'll leave those up if you'd like to pause the video or take a screenshot, you can do so now. Okay, so that's what I wanted to show you about finding critical values, finding p-values. Now that we've practiced that, let's do a real hypothesis test. So let's go to the homework. Give me a moment here. Okay, now we're ready to see how a problem works in real time. I'm going to do a problem with real data, raw data, since that seems to give most of you the most difficulty, okay? So this one says it's actually the last problem on your homework. It says a nutritionist claims that the standard deviation of the number of calories in 1 tablespoon of the major brands of pancake syrup is 60. Notice we have some important wording here. We have standard deviation. Remember, we have 2 standard deviations, so we have to specify which one this is eventually. It is 60, okay? It is 60. Now, you might not know which standard deviation this is just yet. That's okay. But whatever it is 60. A random sample. Okay, here's the sample of major brands of syrup is selected, and the number of calories is shown. This is our sample. So we don't have our sample standard deviation. This is our sigma. This is our sigma, okay? So sigma is 60. This is our, now, when we start a hypothesis test, okay, we always start, regardless of what we're doing, we always start a hypothesis test with 3 things, maybe 4, okay? The first one is we state what the parameter is. So the parameter here is, we write population, we're doing standard deviation. Sometimes we're doing variance, but in this case, it's the population standard deviation, and that is sigma. So we're going to do that. We're going to put sigma there, okay? Population standard deviation sigma. Now, the next thing we do is we specify what the claim is. Well, if you remember, the claim was that sigma is 60. And since that includes equal, if this is the HO. So we're going to say that sigma is 60. It is 60, okay? Now, the next thing we need to do, it didn't say use the p-value approach. When it's not specified, we use what we call the traditional approach. So we're going to write traditional approach. And you're going to put the given information. Now, this is the first place that people get tripped up. It's like, well, I was given raw data. Do I write the raw data? No. What do you need from the raw data to do your hypothesis test? Well, for a test of the standard deviation or the variance, we're going to need n, which we'll go back and check, but this is 18. I counted the values off screen. This is 18. Remember that for chi-squared, we know we need df, so I'm going to go ahead and put that under my df is equal to 17. I'm going to need that for later. Now, I also need my sx, which is my sample standard deviation, which I don't yet have, and my alpha. So I'm going to go now we're going to take a trip, come down here to my calculator, where here's my calculator, where I've already entered the data in. Okay, so here's my data. There they are. Okay, there's my data. And I'm going to now stat, calc, one variable statistics. That's how we do it. Your list is in L1. There's only one list for this. And there are my numbers. Okay. My X bar is my sample mean. I don't need a mean here. I do need my N, as I mentioned, it's 18. And I need my SX. Be careful here to use SX and not sigma X. Okay, SX 64.6163. So here, drop down here. 64.6 is what she used here. If you want to take it to 4, you can. So here we have 64.6163. Okay. That's my given information here. And my alpha, let me go to my problem, says at alpha equals 0.10, can the claim be rejected? So here, my alpha is 0.10. That's pretty straightforward, okay? Alpha is 0.10. Now we actually do the hypothesis test. So step 1 is we're going to state our null and our alternative hypotheses. So HO, remember this is sigma squared. I'm just going to use X for this on my keyboard, X2, to denote, I'm sorry, not X2, not yet. That was wrong. This is supposed to be sigma. So here we're doing sigma, not X2, not yet. Sigma here is equal to 60. That's my claim. Okay, 60. And we're looking for is different. So we have H1 is that sigma is not equal to 60. Okay. This is sigma, oops, this is sigma is not sigma is not 60. So this, let me just see if I can make it work. Nope. Okay, let's see. I don't know what happened there, but hold on. A little bit of a technical difficulty here. There we go. All right, now let's see if I can erase that. All right, so here we have sigma is not 60. So we're going to Draw with the line tool. And I'm doing that. So sigma is not 60. Gotcha. All right. And then we know this is a two-tail test. And we know that my claim is HO. So here, my claim is HO. I've got a two-tail test. And so what I'm going to do now is I'm going to say this. I'm going to write claim behind HO right here. And I'm going to write two-tail test in brackets behind H1. Okay. All right, two-tail test. Now, step 2, aren't you grateful that we practiced finding critical values in problem number 1? That's why I did that. We have to find the critical values for this two-tail test. So let's look at that here. I'm going to scroll down. And if you remember, we use our inverse chi program for that. We divide our alpha in half. So we get alpha over 2 in DF, and we get 1 minus alpha over 2 in DF. Okay. So here we have, and remember, to get your critical values, you use your program. So program, inverse chi. We're going to use 1 minus alpha is 0.10. So we're going to do, actually, I think I'm going to do alpha first. So I'm going to take 0.10 and divide it by 2. And then I'm going to get doesn't matter which one you do first. You have to get both. But if you use the 1 minus 0.10 divided by 2, you'll get the left critical value first. DF, remember, is 17. There's my left critical. My right critical for this is going to be program inverse chi, enter. And this is going to be 0.10 divided by 2. And that's it's going to be 17. We have 8.7 and we have 25.5871. So my critical values here are as follows. Okay. Inverse chi squared of 1 minus alpha over 2 in DF is 8.6718. And my chi right is 27.5871. Okay. So next thing, we write that on our. So here we have this. We have my chi-square value. This is my smaller one. is going to be inverse chi2 of the smaller one, which is 1 minus 0.10 over 2 alpha over 2 and df. And that's equal to inverse chi2 of 1 minus. All right. Okay, this was 0.10 over 2 with a degree of freedom of 17. And that was equal to 8.6718. Okay. There it is. Now your chi-squared larger, your larger critical is going to be inverse chi-squared, and you already saw me do it. So I'm just filling in what I already did. This is alpha over 2 and df. So that was equal to 0.10 divided by 2 and 17. And that was 27.5871. Now, we need to know what the actual test statistic is. So we're going to do step 3. Step 3 here is for us to calculate the test value. Now, if you've looked at the PowerPoint slides for this, you realize that the test statistic formula is the following: chi-squared, and we're not squaring something over here on the left. It's just the name of the, we're going to be squaring some stuff in the formula, but don't feel like you have to take the square root of this like a variable to get that number. No, this is just the symbol, the entire symbol for it. So here, chi-squared is equal to, and here's the formula, it's n minus 1. Okay, we know how to do that. S squared. Now remember, this S, the S comes from the calculator, S squared. And then you have sigma squared at the bottom. Okay. Sigma squared. Now sigma squared, if you're testing a variance, is just going to be the number. But here, if it's sigma, I'm squaring it. So sigma is 60. So what this looks like for this problem is this. You have chi-squared is equal to n minus 1, which you can feel free to go ahead and do that in your head. 18 minus 1 is 17. We also put it there. So we have 17, whoops. We have 17. This is going to be 17 times, I'm going to use the star in my calculation here. S we got from the calculator before, 64.6163, 64.6163 squared. And we're going to divide that by sigma squared. So this is going to be divided when we put it as a line here, and then 60 squared, which some of you might know, but that's okay. And if I poke this into the calculator, poke it in for you here. Whoops. Let me verify that I'm actually sharing the calculator. No, I wasn't. Okay, 64. Okay, so here, let me clear this. Okay. So now 17, and I forgot my parentheses. Times 64.6163 squared. Okay. Close, divided by sigma squared, 60 squared. My chi number is, my chi squared is 19.7165. Okay, so here, let me go back to this for a moment. Here's our catching us up with where we were, okay? I have a little bit different number than she does because I used 4 decimal places on my S, okay? But let's do this. So this is chi squared is equal to, this comes out to be 19.7165, okay? Now remember, step 4 is to make a decision about the null hypothesis. So step 4 here is to say, all right, well, we're going to reject or not reject the null. So we're going to say reject or do not reject the null. So let's look at our drawing and let's see where we are. Here's my drawing. Make a drawing here. Remember, we draw when we are doing the traditional approach. So here's my drawing, okay? And it's a two-tail, so I have a critical value there, and I have a critical value here. My critical regions are always in the tail, all right? So my first critical value is my smaller one, 8.6718. So that's here, 8.6718. And my other one, of course, is 27.5871. Okay. And so remember, this is my non-critical or my non-rejection region. This is my non-critical or my non-rejection region. And then my rejection regions are out here. Now, where is this chi-squared statistic? Well, this chi-squared statistic, let me put it in purple over here. We don't know exactly where it is, but it's past 8 and before 27. So maybe it's here somewhere, right? So in this case, my test statistic falls in the non-critical or the non-rejection region. This is 19.7165. And therefore, I'm not going to reject the null hypothesis. So here, based on the fact that I'm in the non-critical region, I do not reject HO, okay? Now, step 5 is to make our decision. So I'm gonna stick step 5 underneath on the whiteboard here because I don't want to start a brand new whiteboard just to write step 5. So I'm gonna sneak step 5 down here. Remember your step numbers and remember to box your step numbers, okay? Step 5, box your step number here. And you're gonna say, you're gonna use your flow chart and use the exact wording. You did not reject HO, your claim was HO, okay? Your claim was HO and you didn't reject it. So you say, there is not, because your decision here contains not, there is not enough evidence to what? Well, the claim is HO, that means we're going to have the word reject in there. So there is not enough evidence to reject the claim. When you do this, you want to make sure that you underline either is or is not. In this case, it is not. So we're going to underline is not right there. And reject. We're going to underline the word reject. So there is not enough evidence to reject the claim. And that is an example of hypothesis testing for standard deviation and variance using the traditional approach. I hope this helps. Look for some more videos coming soon. There will be additional tutoring sessions, so be aware of that. Okay, I'll see you in my next video. Thank you, everyone.